G'day YouTube, Warble's not a lot here. Welcome to the great Peltier-Powered air screw test. Wherein at we see what works best, or worst. The manufacturer's Chinesium swat sticker, weighing in at 43.7 grams. The first attempt in laminated Casuarina sub rosa and Tuna australis, aka black oak and red cedar, 21.9 grams, and that includes the 150-year-old turned cedar spinner. And Highness radiator and Casuarina sub rosa, 17.6 grams. Smaller spinner, and radiator pine is not as dense as red cedar or Tuna australis. So the hand-carved native hardwood challenges are half the weight of the Sheetmetal Chinesium swastika. So in the interests of establishing a baseline, we need to establish where the air goes when the fire isn't burning. So we add smoke to the system. We add some side lights to the smoke. This is the airflow when the fire is not burning. Once you get over close to the fire, nothing much in particular is going on. 13.6 degrees inside at the moment. 9.6 degrees outside where I'm cold soaking the Peltier-Powered fan. So we light the fire and we wait while it does its thing. Convection runaway. And the temperature is rising. Okay, so here are the smoke trails when the fire's going. And as you can see, the fire sucks in quite a lot of air. Where it really should be reconditioned and resealed. Okay, so consider that your baseline. Before we begin, a few parameters. This stove fan allegedly distributes 150 cubic feet per minute of air throughout the room. I have observed it turning at 300 revolutions per minute, which with 8 inches diameter means it has to have 6 inches worth of pitch, which means its theta angle should be anywhere from 67 degrees all the way out to 13.5 degrees. However, when you measure the pitch angles, for the inner half of the radius, owing to the pressed stiffening ribs on each blade, you've got a very effective negative camber. Then you get 4 degrees, 6 degrees and 8 degrees of pitch angle, which is a reverse helical pitch. So with between 250 and 143 degrees on top of the stove, we'll see how that goes. With the heat sink at 13 and 12.5, and we'll see how that goes. She blows. Very little in the way of tip tracking error. At 36 inches, it's not moving any air there. $18. Yeah, there's a little bit of airflow. Not a great deal though. Move in here, and you can see it's actually sucking. Oops. It's actually sucking the air backwards in the centre there. Look at that. This is really a kind of a pathetic excuse for an air screw. That really should not be happening with any air screw. There's a very, very small donut that's actually functioning. Okay, well that's not very efficient at all. Now, we'll see how we go with the first propeller I've carved for 26 years, which has, as well as a correct helical pitch, it's got a warbles on a lot TLAR air screw or aerofoil section, which was supposed to be like that. 5% camber, 12.5% thick, max camber and max thickness at 30% cord, and I thought that should do pretty well. It's also got, as I mentioned earlier, a spinner made out of 150-year-old cedar. Okay, a little bit warmer, 250. This thermometer won't read above 260. 160, 18.9 at the base, 17.5 at the top. Right, there we go. Took about 21 hours or so to make this, and it has got detectable tip tracking error. It's not bad, but it is there. $36. Nearly 40 inches away. You've got air being blown away by the fan blast. $35 inches. Just there. And in here, there's no recirculation. So yeah, what's going on is this thing's turning at about 360 to 400 revs a minute, sucking so much cold air past the fins that they make one side of the Peltier device colder, so it makes more electricity and runs the motor faster. Thus compensating for the otherwise steep pitch. So that worked pretty well. Last night I actually saw smoke movement at 42 inches, but I had it in a slightly different place on the stove, so maybe it was getting cooler air to pull across the heatsink fins. Now we're going to try the second attempt, which has the same diameter, the same pitch angle. It has a high lift, low speed aerofoil. So we go from warbles on a lot general purpose to a high lift, low speed, ultralight motor glider aerofoil. Up to temperature. Zero tip tracking error, but a horrible hub wobble, partially concealed by the spinner. Yeah, there's a little bit of air movement at the 42 inch mark. Yeah, there's quite a bit of air movement there. Yeah, it's better than it was doing last night. Yeah, it's pretty close. My feeling is that the winner is first one I'd made for 26 years. And the next one will have a boomerang aerofoil. Ciao.